So the first thing that I did was I had to kind of identify the order of integration. So usually when you have your first integrand, that would kind of be like your a to b, and that would correspond to like you're integrating with respect to x, and then your outer integrand where your lower bound is c and your upper bound is d. That means that you're integrating with respect to y. And the thing with integrating, when you're doing double integration, you want to integrate the innermost integrand, and then you move like outward. So yeah, the first step for me was just identifying the order. So like what I did right here was that I know that like for dx, I know that 0 and y are kind of like the limits of integration, and then 0 to 1 are the limits of integration for dy. And then the second step was I have to evaluate the inner integral. So based off the information from the problem, I said that the integral of 0 to y of ln 1 plus x over x dx resembles the given integral that they gave us, which was the integral of 0 to 1 ln 1 plus x over x dx equals pi squared over 12. So because they resemble each other like really closely, I was able to figure out that the integral would also equal pi squared over 12.
I'm not even sure what led you to this conclusion. Just because one function, one integral resembles another doesn't mean that they are equal. You should treat these integrals as functions of y. This integral right here, set it as f of y. This one is f of 1. But you can see f of y is not equal to f of 1 for all values of y. F is not a constant function. Your thing you're integrating is clearly not constant.
So now that I know that the inner integral is pi over 12, now I have to integrate that with respect to y. And now that we know that our limit of integration is 0 to 1, I just integrated this with respect to y, and I had pi squared over 12 times y, and then you have 1 and 0. So yeah, it's just basically b minus a. Yeah, pi squared over 12 times 1 minus pi squared over 12 times 0, and I managed to get an answer of pi squared over 12. You guys have a great day.
By the way, if you change the order of integration properly right here, you'll be able to use this fact to solve the problem correctly, and you'll get an answer that is lower than pi squared over 12.